Next, let's talk about heating. How can we get heating demand reduced? In Britain, we need heating because we have cold winters, reasonably cold winters, and we have crappy buildings. Here's my house. And it loses heat at a rate that is the product of the leakiness of the building and the temperature difference between the inside and the outside. That heat loss is made up by power, and the power required to make up the heat loss is the heat loss divided by the efficiency with which you can create heat. The standard way of heating buildings in Britain is to set fire to natural gas, and natural gas boilers are 90% efficient at turning chemical energy into heat. You might think that sounds good, but it's actually lousy, and I'll talk about that real soon. So we can attack the power consumption by attacking any of these three terms on the right-hand side in colour. You can reduce the temperature difference between the inside and the outside of your building by this amazing technology called the thermostat. You grasp it, you rotate it to the left, and your energy consumption goes down. Rotate it 1 degree and you'll save 10%. Turn it down 5 degrees in winter and you'll save 50% off your heating consumption. I've done it, it works, and some people call it a lifestyle change. Second, you can get the fluff men in to reduce the leakiness. Here's the fluff going into the walls, an extra fluff in the roof, and you can get a new front door to reduce the leakage out of the front of the house. These sort of minor modifications will give you a saving of about 25% in the leakiness of a typical crappy British house. And that's good, that's worth having, it's economic, but it's not the sort of radical transformation we're hoping if we're in the sort of Amory Lovin's camp of saying technology can give tenfold improvements. So what can we add to this 25% improvement? Well, we could go further with the insulation and really improve the performance. Again, admiring the Germans, the traditional German practice with a crappy building is to put 12 or even 20 centimeters of rock wool on the outside to give it a really nice, warm, fluffy jacket to keep it warm in the winter. But there's another option, which is to attack the efficiency of heat creation. The boiler that burns gas is 90% efficient, but we can do much better, because what we're after is low-grade, low-temperature heat, and that has very small value, and it can be delivered in a much more efficient way than setting fire to high-grade chemical energies. This technology is called a heat pump. Probably you already know about it, but let me tell you anyway. It's a back-to-front refrigerator. Take your refrigerator. It's making the inside of the fridge cold. How's it doing that? Well, it's doing it with some pump that moves the heat from the inside to the back. Reach around the back of the fridge and there's a grill and it's warm, yeah? So now, you take your fridge, you open the door, put it in the kitchen window, and now the open door of the fridge is opening the inside to the garden. So the inside of the fridge is in the garden, you keep it running, and now it's cooling down the garden, and the grill is still warming up the kitchen. And that's how a heat pump works. So heat pumps are back-to-front refrigerators. They're also identical to air conditioners, just back-to-front air conditioners. It's exactly the same technology. And in Japan, they've recognized the importance of heat pumps and the efficiency of heat pumps for several years, indeed decades. And they've had an efficiency drive that says all heat pumps must be better than average. And the result is fantastic. Here's Pumpu and Tankman, and they've got amazing gloves and capes and eyes, the lot. They're wonderful. Pumpu's performance, coefficient of performance, is 4.9 according to their website. So he's not 90% efficient, but 490% efficient. You give him 1 kilowatt hour of electrical energy, and he delivers 4.9 kilowatt hours of heat into the kitchen and into Tankman. So he delivers hot air and hot water. Now, you can't trust everything you read on websites, but studies by the German Energy Institute show coefficients of performance between 3 and 4. So 300% efficiency is indeed possible. That's roughly 3 or perhaps even 4 times better than the standard way of providing heating. So the suggestion is, let's go for heat pumps as a major way of delivering heat if people want hot water in homes and if they need hot air at some times of year. Use heat pumps. These can either be ground source heat pumps that suck heat out of the ground, which originally came from sunshine. People call this geothermal power sometimes, and that's not true. It's not geothermal energy. It's energy that came from the sun. And there are air source heat pumps, of which Pumpu is an example, which pump the heat from the air in your garden directly into the house. So we can make things more efficient. We can make transport more efficient. We can make heating more efficient. And there's one more technology I'd like to emphasize in addition to the electric transport and electric heating. And this is a technology called reading your meters. If we can get people to read their meters and to understand what the meaning of their meter reading is, I think we can get enormous savings, because people do waste a lot of energy, and it's quite easy to change lifestyle to save some of that energy. And I found this out because a friend asked me when I was writing my book on sustainable energy. He said, "How much energy do you use?" And I was embarrassed that I didn't actually know my domestic energy consumption. I thought of myself as a green person, but for 15 years I'd just been piling up the meter readings without looking at them. And so I started looking, and I started reading the meter every week. And the effect was that during that year of reading the meter every week, my energy consumption for gas went down from 40 kilowatt hours per day on average to 13 kilowatt hours per day. Similarly, my electricity consumption went down from 4 kilowatt hours per day to 2 kilowatt hours per day. So I halved my electricity, and I more than halved my gas consumption, because once you start reading the meters, you become a scientist. You do experiments, you try things out, and you play the video game of trying to beat last week's high score. Here's the graph I made of my electricity consumption before I tried being a little bit obsessive, and after. So before I left the vampires on, so I had not just the phone charger, but things like DVD players, stereos sitting there on all the time, home cinemas, and computer peripherals, modems and things like that, all on all the time. And I tried switching them all off, and I found a saving there of about 45 watts, which is 1 kilowatt hour per day, roughly, which is 1% of an average European's consumption, so it's worth having. And so that changed my life. And now when I've watched the DVD, I take the DVD out and I switch off the DVD player. It's a simple lifestyle change. It doesn't cost much, and in fact it makes money. The total saving of this lifestyle change is £45 per year, which I can spend on an extra holiday in Lanzarote. That brings us to Jevons paradox, which is something to bear in mind. Whenever we say, oh, technology can make things more efficient, well, yes, if things get more efficient, maybe we'll end up using more of the stuff we are trying to save. So we need to bear that in mind and try and figure out if there is a solution.